Thanks for joining, everybody.
Yeah, thanks everybody. So, yeah, this is this week's edition of Water Talk. We're talking about taking your data and analytics to the next level, specifically looking at Info360 Insight, giving you a little bit of a baseline and then going into some of the new and exciting features that we've been adding here at Innovise. And Pete's team has really been working hard, and we're really excited to present these to you. And so your hosts today are going to be Pete McIntosh, who's a product manager here at Innovise, and I'm Hunter Sparks, and I'm a systems engineer here at Innovise.
Whoop.
Got a little excited there. The goal for this is really to create a community where we can come together, ask questions. This is an informal presentation. Really, we want this to be more of a discussion with you guys. So please feel free to utilize that question area in the main chat and ask your questions. We're more than happy to respond to them. We'll try to get to all of them here. If we don't, then we will follow up with you afterwards. Some upcoming events and water talks that we have next week, we are going to have a deep dive into hydraulic modeling, back-end data management. So we're going to be kind of looking at what is going on in the file structure of some of our products. And then February 22nd, we're going to have swim modeling and common stability problems and tips for better modeling. I do want to let you guys know that those are going to be at 10 o'clock Pacific Standard Time. So we're pushing those an hour for some internal things that we have going on. So with the time change, it will just be an hour later for next week and the week after. And with all of that said, Pete, I'm going to go ahead and hand it to you.
Sounds good. Hunter pretty much covered everything. We are going to target about a 45-minute session today. We like to leave a little time for Q&A, and also we just don't ever like to spill over. I'm going to lead off with just some presentation stuff because this is a relatively new tool, and we have a lot of people on this call who just aren't really familiar with this tool set. So I do want to start with a high-level overview, and then we're going to focus on what some of our latest tooling is that's available in the solution and how it really maps out to the job to be done or to the problems that you're trying to solve as a utility. Real quick, Insight is our new cloud-based operational analytics solution. It integrates with your SCADA systems, but it really also integrates with any data warehouse that you may want to leverage. This could be your LIMS. This could, of course, it could be your SCADA. This could be even weather feeds. This could be other non-SCADA systems like pressure loggers. Doesn't matter, right? We take in all forms of data and we leverage it to give you the business intelligence that you need surrounding your utility. We also integrate directly with your Innovise hydraulic models. This greatly facilitates your calibration validation workflows and gets you, enables you to get much closer to a live modeling type of scenario. I'll really kind of cover off more of these talking points as we show some deeper dive on the slides. But the net takeaway, the objective that we're trying to get our customers to is that, especially with clean water systems, which is what our focus is going to be on today's talk, right? You want to be operating as absolutely efficiently as possible. And one of the ways that you know that you're operating as efficiently as possible is you have, minimal water loss in your system, that you have operations teams that are focused not on triage of disruptions or perturbations in the system, that they're always working on prescribed work, that they're not, constantly in as we want to say, firefighting mode. And that, a highly efficient operating system is generally just humming along, and you find any system disruptions when they're very small and very early in time. This allows you, of course, to stretch your operating expenses because you're not spending lots of time on retroactive sleuthing to find where problems are happening in your system. It's basically a solution that is proactively keeping you informed on all aspects of your system behavior. And then when something does happen, right, nothing in the world is perfect. When something does happen, we also provide tools that allow you to simulate different type of shutdown scenarios so that you can maximize, or so that you can ensure the best incident response if you do need to do some sort of an isolation. Our incident response workflows, there's not what we're going to really focus on today. We have talked about this in previous webinars, but it is about ensuring that you minimize the fewest people for the least amount of time possible, right? There may be some outage, but it's about helping you minimize those disruptions. This is a fully managed SaaS. This is a cloud solution. There is a very strong reason why we have developed this as a SaaS, because it is extremely flexible and it is extremely scalable. There's a lot of infrastructure that goes into this solution, and we really don't want to burden our utilities with all of that IT infrastructure. We take all of that on. We just need data connections. This also allows you to scale up. You may pilot, as an example, with 1 or 2 zones in your system, and then start to expand system-wide. This basically enables you to do that seamlessly. You yourself do not have to implement or install any additional hardware or software in your system to scale rapidly. From a functional set, we have a wide range of tools of dashboarding, KPI, and analytic tools. That's actually going to be our focus of today's webinar in terms of what's new in the solution and how it helps you achieve your objectives. We do have bidirectional flow with hydraulic modeling tools, InfoWater Pro, WS Pro from Innovyze, that allow you to really maximize your calibration validation workflows. And just various other reasons why you're going to want to pass SCADA data into or other IoT data into your hydraulic models. You can set boundary conditions, all the other reasons there, and then the other return workflow where you can create a bunch of simulated results, push them right back to the Insight platform, and compare your simulated results to a large time series data sets, and really kind of fine-tune your model tools so that your simulation outputs are matching reality. We have built-in 24/7 event monitoring and alerts, the incident management workflow that I talked about, and then a really key point that we emphasize on the platform is data integrity. There's cases in this platform where, not in this platform, sorry, in the utilities world where SCADA data are dirty. There are a lot of dropped values. You have thousands of sensors running constantly, and just data hygiene is always an issue. So we have a lot of built-in tools that scrub your data as it come in the door. This ensures that your analytics are very trustworthy, and are not skewed or incorporating places where you may have dropped values, or where a sensor maybe went offline for a little bit. Those are very, very real situations, and if you're using that data in any type of analytic, it is going to reduce your trust in the system. So this is a huge, huge pillar for us in terms of ensuring that this is a highly, highly trustworthy and authoritative solution. So when we dig just a little bit deeper into some more of the functional areas, we have a lot of the granular dashboarding and charting tools so that I can view my time series data or my instantaneous data for level sensors, pressure sensors, flow, volume, pump, run times. So we have the granular analytic tool set that allows you to visualize your current information relative to all of your past performance for those given sensors. Then we have a second level of Meta analytics. These are taking all of the raw sensor information and turning them into a higher level analytic. What is my zonal or system-wide usage? What is my zonal or system-wide leakage index? In the incident response world, right between these two, like what is my potential impact if I modify these several service valves to do some maintenance. And Hunter and I will show you some more of the custom analytics that you can start to investigate or build using our granular solutions. You know, one of the things I have absolutely found is that no two utilities are exactly the same. And the measures that one utility wants are not necessarily exactly the same as how another utility wants to measure them, or how they want to compare them. I mean, basic things is you may want raw measurements of system-wide pressure and to look at regional pressures relative to average pressure, but you may want to some other group may want to see that as a normalized, right, as a function or as a percentage of what a baseline value is, and see how far they are deviating from a baseline value. Our objective is to make all of this available to the users so they can visualize and analyze exactly the way that they want to do it. I'll show briefly just the interactive map views. Obviously, all of our water systems have a high spatial component, and is certainly our objective that we make sure that this is very, very geographically, contextually built, so that you can, not only get the analytics and understand the what and the how, but you also know the where. So what are some solutions, some problems and challenges that we know that our users face? There is definitely a lack of visibility into system performance without a real-time analytic solution. You may have SCADA dashboards that are blinking and flashing and showing you current readings on everything, but they don't necessarily show you a holistic view of all of the aspects of your system that you may want to know. For example, I want a single chart that's showing me all of my storage levels or my reservoir levels, for the last 24 hours, for the last 6 months. I want the ability, right, as a user to easily drill and slice and dice the data that I want to get at. Another challenge, of course, is non-revenue water for any utility, and understanding where it is and how significant it is. To get to this data now is often sort of painful and, I don't want to say tedious, but let's say tedious. If you don't have a live, operational analytic business intelligence solution like Insight, and you want to do something like a water audit, what are your options? Probably to download gigabytes and gigabytes of many different sensors and hand crunch all of that, and hope, as we talked about before, that you don't have a lot of dirty data in there that are skewing your results. And if you do, what is your solution for cleaning that data or ensuring that you have data integrity when you get to those answers? When you want to get to those answers. There is certainly a need for these purpose-built analytics like non-revenue water. I have RDI here for sewer systems, but zonal volume usage, leakage indices, right? I mean, having these living real-time KPIs is highly valuable to utilities, right? 99% of the time, you want your system, you want these, in fact, you want these dashboards and these analytics to be boring, right? Because that means you're operating well, right? You want a nice graphical interface to show you the elements of your system, but in essence, you don't want the blinky lights. You want nice, just green light, proceed type of dashboard. Having these living these living analytics is really, a facilitator to ensure that you're getting that information constantly updated in real time. The objective here is just so also that you're always being proactive. You don't want to be reactive. You don't want to always be triaging things that are happening. You want to be, observing your system always in real time, seeing if any aspects of your system seem to be approaching out of bounds or exceeding desired bounds, and proactively getting out in front of it for maintenance or inspections, rather than just waiting for something to fail or a burst to happen. And then just having transparency, cross-team visibility, having this information at everyone's fingertips, having it be live, having it be updated continuously, huge value in all of that. So we have talked about proactively monitoring your systems, right? The idea that you want to proactively understand poorly performing areas of the system and get out in front of it. Really, we really want to facilitate the digital twin concept. The idea that you have live models, that your system dashboards are always live, that any simulation that you do is going to be highly trustworthy and highly current based on all of your extremely real-time system boundary conditions, right? That not only are we, giving you just a description of what your system is, but that you can use this digital twin concept, especially with our hydraulic modeling tools and Insight, so that you have extremely accurate predictive capabilities and what if scenarios. And then, of course, the idea is that it's to minimize system disruptions, to get incidents, to get disruptions down to a minimum, by always being in front of the situation, because you have these real-time analytics, KPIs, and dashboards that are showing you exactly what's happening in your system. And I'll show you a couple of neat examples of how this works. So I'm going to pivot here into some functional additions. I won't spend too much time talking here because we're going to show all of these things. But we have added, at least since I've last talked in a water talk, we've added a lot of new dashboarding and analytic capabilities. So we have tabular data views that allow you to, either view. Right now you can, of course, view all your data in charts, but now you can view your data tabularly as well. And the more exciting part of that is if you add multiple sensors to a table, it allows us to provide for you ranked tables so that you can look at and cross-compare and sort a lot of the key metrics of a system. A great example is, let's say I have 20 DMAs. For anybody who's not familiar with DMA, I did actually just add a few slides at the end of this before I get into the demo, and I will sort of cover off that DMA concept. But let's say you have 20 DMAs, district meter areas, in your system, and I just want a rank table that shows me, over the last week what my zonal DMAs are, and I want to compare them, and I want to sort them through table behavior. Maybe you have 117 pressure zones, and you want to do the something similar like that. That maybe that's just a little bit hard to really process in a chart when you have 117. But if you can sort it tabularly, you filter the big stuff to the top, the ones that you really want to look at. We have compound pump performance charts. This allows me to overlay multiple data sets in a pump performance chart. We've added pump status charts so that you see exactly what your pump cycles look like. Pie charts, we all know what a pie chart is. We've all used them probably 1,000 times, but this is a new addition that allows us to look at comparative metrics as a function of whole. and a sensor comparison chart. That's what we're seeing up here. This is a similar concept. It's a comparative type of chart of the pie chart, but it allows you to compare the latest values for a collection of sensors simultaneously. And I'll show you some of the levers that we can switch on that. Something I'm really excited about is we are now available to, or we now have made available the custom analytic toolset to Insight. This is right. We're at our first version of this. We have ambitious tools for this going forward, but what you can use it now for is basic math operations. Maybe I want to take 4 of my pressure sensors and I want to compare them to an average of the 4, or reservoir levels, or flow meters, or maybe I want to normalize my zonal volumes to a system-wide volume to understand that as a fraction of whole. There's so many slicing and dicing for the custom analytics that we're really excited to bring this forward. These are usable across any time series data, and they do incorporate any of the value mapping to ensure data integrity. Sorry, value mapping is our functional name for when users, or not for when users, for when the system really is scrubbing your data as it comes in the door. So it incorporates data scrubbing, is really what I should have put here. So what are some examples of this? Maybe you want to subtract head from a sensor because there's actually a physical offset from the discharge at a pump to where the actual sensor is. This is a very real life scenario, so we allow you to make that correction using this tool. Maybe you want to do bespoke volume analytics when the right flow data are not present. I've seen this in some sewer systems where there actually isn't a very good flow measure out of lift stations, and that there is some special magic, for lack of a better term, that we can apply to measure and get to volume data. I'm sorry, when the flow data are not necessarily present for us to work with. Unit conversions is a very obvious thing, and maybe you want to do something like adding volume and billing sensors so that you can see combined values. I may have 20 DMAs, but I may have 4 larger regional areas that I want to analyze collectively. So this allows me to group these things and analyze them as a collective.
And just touching on this feature, Pete, I really, like you said, really excited about this one, because I would say when we're talking to customers, get in front of customers, that is one of this tool is something that they have been clamoring about and asking about, right near the top multiple times. So just kind of wanted to echo what you were saying, how we're really excited about what it can do and what the future of this can be within the software.
Absolutely. Look forward to showing it off today as well. Real quick, we've just added some more custom styling options to the mapping tools. Basically, further enabling you to have the map look and feel the same way that you want it to, or that you may use in other tools. This is a journey. We're going to continue to add more symbology, more colors, more options. So we look forward to hearing from you if there are additional map styling tool sets that you would like us to consider. And then I'm gonna here in just a second pivot over to the demo, but again, I would like to circle back. What are the problems that we solve with the solution? Another set of example problems is looking at zonal drift over time. Do I see my leakage, or do I see my usage drifting in a way that either I don't expect, or maybe it is a way that I do expect because of seasonal differences, but I want visibility into that, right? I want to know if my non-revenue water is going up, and if it is going up, where is it going up, and how much is it going up? understanding how much water is lost in a leakage event. Maybe I do have a system disruption, and we fixed it within 24 hours. But what was my water loss in that event, right? Wouldn't it be nice if you had a tool that could basically provide you that information very quickly and very easily, right? It's like, cool. We lost 24 million gallons because of this burst, and with 2 clicks, I got that information. Our booster pumps or lift station pumps or groundwater pumps performing as expected? Are they working the way we want? Are they working within bounds? Do I need to look at my maintenance schedules for any of these pumps because they are having some serious drift in their pump performance? That type of thing. At a glance comparison of different areas of your network, both for current and past performance. This is just your generalized business intelligence tool set. How am I now, and how is this relative to last 6 months of operation? And then really that robust analytics and dashboarding with the data scrubbing tools, right? Making sure that our users don't have to manually do any of the downloading, the processing, the scrubbing, that it's all live. Once you set it up in our system, it just continuously operates, continuously shows you the most current values, and it's always analytic ready, and especially with our data scrubbing tools, it's always highly reliable. Okay, I don't know how I just did that, but I really quick before I jump here, is that when we're talking about DMAs, right? A DMA is a district meter area. We recognize that definitely not all utilities necessarily have their distribution systems broken down into district meter areas. All of our tools work system-wide. You do not have to have DMAs. We recommend DMA configuration, right? Which is, don't get me wrong, it's not like as simple as turning on a light switch. You do have to have the right sensor placement, and you have to have the right zonal connections, physical pipe connections. But the idea of a DMA is that all your inputs, your storage ins and outs, and all your outputs, so that you can very accurately do a water balance at a smaller level within a sub area of your system. The benefit of this is that when you do have drops in system performance, you know where it is, and it's much easier to quantify, much more easier to accurately quantify the elements of poor performance within a system. And I'll show some examples, just some output examples of that. How the mass balance tool works, and really how the ILI works too, is right based on your system zone configuration. We track your net inflows, we track your storage ups and downs. Of course, bring in any groundwater that may be pumped specifically within this zone. Track all of your consumption. And this allows us to get to non-revenue water. If we know all of the built consumption, we know all of the ins and outs, we can get to non-revenue water. And then we use non-revenue water with some other elements of your system that include pressure, and this is probably a better one, that include pressure and some other specific characteristics of your system, like your material types, the number of connections, the length of mains, the length of lines. I'm not going to belabor the specific math that goes into it, but using your zonal water balance information, using your non-revenue water, using the pressure and other system characteristics, we can derive a leakage index at a zonal or at a DMA level. Really just kind of covered off these exact topics on this slide, and so I think I'm going to go ahead and pivot over to the software demo. Again, if anybody has questions as I am talking through this, please use the question area in chat, and we will, of course, try to get to those. So this is your entry point when you get into Info360 Insight. I am going to just really quickly jump over into a workspace that I have that is demoing in action a lot of these new tools and a lot of the analytics that these new tools help us show. The GoToWebinar consumes a fair amount of my bandwidth, interestingly. So give it a second here and this will start loading up. Okay, again, as we talked about, integrated map views, you know it, really fast. I meant to show this. Well, take me just a second here. I'm gonna turn off my camera because I think maybe that'll give me a little bit more bandwidth. One of the things that we have now added is this new style editor, right? So I can choose any level and I can say, yeah, I'll just keep that. And I'm just gonna change this to be some other color so that you show that immediately updated on my system. I can change the symbol. Maybe I want a sensor to look like, who cares? That's not the right symbol for this, but you get the idea. So we're just really quick wanted to show that. We are now showing incidents on the map as well. So if I click on an incident, I can get some information about it and I can view the details on this incident. You can see here it starts to populate, tells me all the activity that is associated with incident, and I could go in and view the actual impact associated with this. But that is out of scope of today's webinar. So let me go ahead over to our demo workspace again and just talk through some of the visual analytic tools we have added. And then I'm gonna hand it over to Hunter in about 10 minutes to try to keep us on time, who's also just gonna drill a little bit deeper on the custom analytic tool. So I've obviously pre-populated this because it would be slightly tedious if I made you sit through all the buttonology, but we have here a sensor comparison chart that allows us to compare burst volumes per zone across different DMAs, right? This is a case where we can see DMA3 had a burst volume here of specifically 0.11 million gallons in that zone. No burst volumes in these other zones. Good, that's good. And some of these other, some of these other burst volume losses that we've identified, I mean, those could be related to flushing or fire flow events. But what we can get, using our tools is at this metric. Like from a zonal standpoint, what was the volume of water, unexpected water loss that I had for a given time period. I'll show you real quick, and I won't go through all this, but some of the configuration options, right? If I wanted to look at this particularly as, just some of the configuration options that I wanted to show here. Again, this is just to allow you to get the graphs to show you the way that you want it to show. And I can look here at, different resolutions. This is, I've already summed this up for a December, but maybe I want to look at some daily series here. We'll see if this gives me. Yep, I don't have daily data available on this one because I've already summed it up on monthly, so I won't see these other intervals at this time because this is already a pre-processed data set. But these are the options, the off-the-shelf options, where you can slice and dice and say, hey, I want to see hourly, daily, weekly, and we plan on adding more resolution views to that. And we're actually going to add some more specific time box elements around here so that you could say, hey, I want to know from August 1st to August 4th what the burst volume is. Another analytic using the same visualization type, the same chart type, is we can get to DMA volumes. We can summarize and compare DMA usage volumes, again, hourly, daily, weekly, etc. We can look at system-wide usage trends, right? When we look at this is like the combination of all my DMAs rolled up into one. Obviously, we see peaks and valleys here. The valleys strongly correlate with weekend events, or not weekend events, but just weekends. And then I can overlay, and as you see here, I've overlaid a moving average on this chart. How did I do that? Just so you can see real fast, is I just have this set as a reference chart with a specified reference period, and there's a lot of different ways that you could overlay the reference chart. In fact, well, I was going to show you how you could change the color and all that stuff on the reference chart, but that's going to sort of kill our time. But another really good takeaway of this is, right, first of all, I'm looking at my my overall daily pattern for system. I'm smoothing it out and looking at more of just what is the trend of it. You can see, one of the things is I go further and further back in time, and let me just go to about this point, and you can see, right, as we get further and further into summer, I'm getting more and more water usage as more and more irrigation is required because it's getting hotter and drier, right? This is very much expected, but being able to see this as a trend line is very useful, and it makes it pop out immediately of sort of what my baseline usage looks like and how it is or is not increasing. So if I want to look at and cross compare zonal leakages, I've pre-built and populated the zonal ILIs using our ILI tool. I can compare again results across zones to see better versus worse performing of the system. So I have zonal ILIs here that represent leakage indices for the different zones. Now I should have put these two right next to each other. Let me go ahead and just drag and drop these around real fast, and we can see here what's kind of interesting is even though I have a worse leakage for zone 3, I'm having more absolute loss worse leakage in zone 2, I'm having an actual absolute worse loss in zone 3. So it has lower leakage, but it's got a much larger footprint and it's pushing a lot more water through. So if I was an operations team, I would spend more time looking at zone 3 to get that water loss down than I would at zone 2, even though it's got higher leakage. So we'll look at a single zone ILI, and this is what I think is a very powerful metric in our tool. Is there are variations, there are normal variations in these discrete calculations like ILI. But really what we want to see is trends, right? What are the trends? So if I expand this chart here to show me a trend, it is very clear that my ILI is going up again over the summer pattern, and again probably correlated to higher usage. So in a sense, this is not unexpected, right? I have higher loss and higher leakage when I have higher usage in a zone. This at least allows me to quantify it, and it allows me to, looking at that trend line to see how severe it is, right? Is this something I really need to be concerned about, or is my leakage going up, at an expected rate with zonal usage, and I don't need to drop everything and go triage this particular zone. When you start to see sharp climbs, and of course when you start to see peaks, I don't have a peak data set that shows real great. That's when you definitely know that you have burst events that you need to go isolate and triage. This is just real quick. Using our pattern tool, you can develop, a 24-hour daily or diurnal pattern. This is immediately and readily exportable to your modeling tools, so you can bring in patterns. This is, again, super simple, one-click type of tool builder. This is an average analytic. So actually what I have here is a collection of discharge pressures, and this purple line here is my average pressure. There's nothing, like the good news about this is there's no big disruptions, or there's no big bad parts or areas of this. It's like all of my pumps are operating pretty normally, but this just allows me to see how each of them relates to average pump discharge pressures within or across zones. DMA volumes, again, having now calculated my mass balance and my usage across, I can compare all of my volumes as a function or as a percentage of whole. We've talked, I briefly mentioned the pump run setting. The advantage of this is, the value of this is I can just see exactly what my pump cycle times look like. This is probably not the most interesting pump data, but it allows us, again, to see at a glance how and when all of my pumps are cycling on and off relative to each other. So what you would do, and really probably most likely in combination with that, is then use a pump performance chart. Pump performance chart allows you to compare your sensor readings relative to manufacturer specs. And as I mentioned, we have compound pump performance charts, so I'm going to focus on this area here. And we have two series in here. One series is the raw pump discharge data, but I know that there is physical offset from the pump to the sensor. And I actually want to account for that. And I used an analytic to account for that. And I'll show you what that analytic looks like. But just to say, hey, I needed to add in a little extra head, or in some cases subtract a little extra head. And really what that has done is it's pushed up that data series from the raw readings to what the system actual should be. And it is showing me that, yeah, my pump is actually really, really close to this curve, whereas the raw readings, might cause me to think that I had some propeller degradation because we're dipping below the manufacturer curve. So that is with that. And then just a couple other items, right? We've got gauge charts, nice handy gauge chart here. One thing that we can show on the gauge charts and is to say, this is not a very real life example, but I'm going to say my desired range is 16 to 20. And if I update that range, basically it's going to update the chart and it's going to say, well, here's your threshold desired range, you're out of range, kind of updates the visual so you get a quick and immediate view that something at an instantaneous reading is below where you want it to be. And as I talked about the ranked table, so I have here a collection of DMA flows for, I'm going to go look really fast. How did I set this? For weekly DMA flows. I should have just put that in the title so I didn't have to go do that. And this allows me, again, in the ranked table thing to say, like, cool, I want to know, from a comparative quick view standpoint, like where is the bulk of my action in my system. I'm gonna show you just how I developed my particular pressure correction analytic, and then I will hand over to Hunter, who's going to show maybe a little bit more detail on how we configure this. But what I have done here in our custom analytic tool is I've created two inputs, right? I've got the pump pressure input. I've got the pressure correction factor. So I'm adding in just an extra 50 PSI. And then I get an output, which is the raw reading plus 50 into the pressure corrected output. Really simple, right? How we do it, you can configure input here, and I'm just gonna do a I'm just making this up as I go, but just to show you what the process is for creating this analytic. So I have added a level setting here. This is, and then if I want to just add that in, which obviously this does not make any sense from an analytics standpoint, but from a buttonology standpoint, you get what I'm doing. And now I have added in a level information into this particular analytic. Anyways, that's how you build these analytics. And I'm going to go ahead and clean this out. And then when I'm done, I can calculate it. I get the output, and then you get a calculated result here. If I make any changes or I want to change date or time range, I can do that. And these analytic charts have the same interactivity, that I have with all of my dashboarding elements. And what's nice is if I really want to, I can put this into a workspace. And if I wanted to, I could hop over to that workspace. But this output data set from the analytic is now ready to be used across my system, as I now have a pressure corrected discharge valve pressure. So I will now hand it over to Hunter and let him show.
So some options of what we've done is you can figure out non-revenue water on a daily, weekly. Really, if you configure this to a different time period, different set time, as well as changing the output and changing which time step you're actually working in, so that you can actually look at these custom analytics at a different scale. It also gives you the option, because let's be honest, we've all been been trying to work on something. Maybe we were working on some coding and we just couldn't get it to work, and it never really told you what was going on. So what we've done is we've added this validate tool, so that if you put in information that isn't going to calculate correctly, it will actually tell you which character and where it is having issues. The different data sources, you can give it a name, and then this is actually where you're tying it to your sensor. But when you're creating these custom analytics, you can also create a constant value so that you can subtract that different pump head, different tank head, and then I will go ahead and create a new analytic, name it demo, just so that I can show you what it is like when you are actually creating an output. So if you go into the output, it is going to give you a name. There is also a bunch of different types. So whether you're doing billing, doing current, a flow rate head, different sensor types that you can pull in, and each of these will have a different output with a different unit that you can put in. You then just put in the expression that you were trying to work on, and then you're able to calculate the results. And then you can also come in here, and let's say you actually want to look at it on a different time step. You are able to edit these so that it only pulls the time step that you are actually trying to look at. And then it can be, something as simple as looking at the average pressures across a certain DMA, where you're just adding them and dividing by the numbers. And then something you can also get as complicated as something like a little bit of tank turnover, where you're actually looking at a bunch of different inputs that come into a little bit more of a complicated analytic, just to show you that, if you can use mathematical functions, the custom analytics are able to handle that. So that's really what I wanted to get across. It was a little bit quicker with some of those technical difficulties, but I will go ahead and pass the sharing back to you, Pete, if you want to just kind of share that last couple of slides in case they want to get in touch with us.
Yep. Excellent. Get over to this one. So thank you all. We did go a little bit longer than
It was an
expected,
exciting one
but
with that technical difficulty, right?
Too much, right? Fortunately, that was a minor blip. If I know we touched the surface on a lot of things here. absolutely, if you have questions, please contact myself or Hunter. And if you want to schedule a little bit more of a deep dive, one-on-one, we are here for that. And we would gladly sit down and kind of walk through what your objectives are and how we can tailor the solution to hit your objectives. So,
And we do have one question that came in, and Pete, I don't know if you can answer this one, but as we have more built custom tools, would we ever have a user forum where people can share tools that they built?
Mr. Swanson must have pulled out his crystal ball, because that is absolutely our plan. Yep. This is the idea, is that we are building these with the explicit intent of them being shareable and templatizable across, right, either within your organization or like a public public user contrib of these tools that we can all share together. So 100%.
And I meant to put this as a poll. So before, with 2 minutes left, I know some people have dropped off, but if you could just put in the questions or in the chat, if you would be interested on, doing a little bit more of a deep dive, a water talk that centralizes mostly around those custom analytics. This was kind of an overview of all the new tools. But if you'd be interested in us having a water talk specifically on the custom analytics, since we just kind of touched the surface on it today, if you could just say so in the chat and the questions respond yes. I apologize for not setting up a poll, but we'd definitely be interested to hear if that would be a topic that you guys would be interested in moving forward for a water talk.
Excellent. Well, I'll go to mute, but I'll leave this open for another minute or so, just in case any other questions come in or people want to put any more stuff in the chat. But thank you all for joining us, and we hope to see you in our next water talk.
Really appreciate
Since
everybody.
I have this up, I'll go over and just remind ourselves what the next water talk is.
Appreciate that. Yeah, looking forward to that one and ones in the future, and looking forward to seeing everybody there.
Fantastic. Well, I see our people starting to drop out. So have a wonderful day, everybody. And thanks again for your time and your patience with our strange little audio difficulty there.
Yep. Thank you, Pete, for joining us and running us through the tools.
Absolutely.